Welcome, my dear learners, to another exciting episode on this very channel. From today up to the next few weeks ahead of us, we will be diving into these two topics, indices and then logarithms. They are two different topics altogether, but they move hand in hand because one is the reverse or the opposite of the other. Let's start with indices. Now, indices is the plural form of the word index. And index means power. It's the same as what? Exponent. So index is the same as power and it's the same as what? Exponent. When we talk about indices, it is the study of powers of what? Numbers. In other words, it is a simple way of writing what? Numbers. The task of multiplying a number by itself a number of times gives rise to the idea of what? Indices. Indices is widely applied in mathematical expression, algebraic expression, trigonometry, geometry, scientific notation, differentiation, integration, and so on. So the concept of indices plays a key role in mathematics and other related subjects. This is one of the main reasons why we have to learn and understand the concept of what? Indices. So let's set the ball rolling. Let's consider the number 3. And this number 3 is multiplying itself, let's say, 4 times. So we have 3 times what? 3 times 3 times 3. We can observe that the number 3 is repeating. So it becomes a repeated factor in this multiplication. The number of times that this 3 is multiplying itself is what we write as an exponent to this number. So how many times is this 3 multiplying itself? It is multiplying itself how many times? 4 times. So we are going to write it as an exponent to the number 3, 4 times. Now let's also consider the number 2. And let's take it that this number 2 is multiplying itself, let's say 5 times. So we have how many times is this 2 multiplying itself? It is multiplying itself 5 times. So the number of times that this 2 is multiplying itself is what we write as an exponent to the number 2. So we have 2 raised to the power 5. Also, if you have the number, let's say 5, multiplying itself, let's say 2 times. So we have multiplying itself. It is multiplying itself 2. So this 2 is what we write as an exponent to the number 5. Now this form of writing numbers 2 raised to the power 5, 3 raised to the power 4, 5 raised to the power 4 is what we refer to as what? The index notation 4. So we have index. So 5 raised to the power 2 is in the index notation 4. The number 3 here becomes the base. We call it what? The base. And then the 4 becomes what? The exponent, the power, or the index. Similarly, this index notation 4, the 2 becomes what? Our base, and then 5 becomes our index, our power, our exponent. Similarly, this index notation for 5 raised to the power 2, 5 becomes our base, and then 2 becomes our index, our power, and then our exponent. Now let's consider this example also. If you have, let's say, 7 raised to the power, let's say 3, this is in the index notation form. Now this means that the number 7 is multiplying itself how many times? 3 times. So we have 7 times 7 times 7. Similarly, if you have the number 8 raised to the power 4, this index notation means that the number 8 is multiplying itself how many times? 4 times. So we can therefore write this or expand this as what? 8 times 8 times 8 times 8. Now with these very few concepts that we have gained, we can generalize and say that A times A times A and so on can be written as what? A raised to the power n is the base, and then n is the number of times that the A is multiplying itself. Now that we know this, let's move to the laws of indices. Laws of indices. Now let's consider the number, let's say 3 raised to the power 2 multiplying, let's say 3 raised to the power 4. Now we want to write these numbers as a single notation. Now we know that this can be written as what? 3 times what? 3. And we have our multiplication sign. And we know that this means that the number 3 is multiplying itself how many times? 4 times. So we can write this as what? Now, how many times is the number 3 multiplying itself? So let's count it. 1, 2, 3, 4, 5, 6. So it means that with this expansion, the number 3 is multiplying itself how many times? 6 times. So it means that we are going to write this as what? 3 raised to the power 6. I guess you are following. Let's take another example. We want to write the number, let's say 5 raised to the power 3 multiply, let's say 5 raised to the power 2. Now we want to write this as a single notation, and this means that the number 5 is multiplying itself how many times? 3 times. So we can write this as what? 5 times 5 times 5. Then we have this multiplication. Now this means that the number 5 is multiplying itself how many times? It is multiplying itself 2 times. So we have 5 times 5. So in all, how many times is the number 5 multiplying itself? We have 1, 2, 3, 4, 5. So it means that in this expansion, the number 5 is multiplying itself how many times? 5 times. So we are going to write it as 5 raised to the power 5. Now looking at these two examples, is there any other way by which we can achieve these results without fully expanding the whole of that? Is there any other way that we can achieve this result without fully expanding this? I believe you are saying yes, because we can observe that when we sum the powers of these two numbers, it gives us the power of that. When we sum the power of these two numbers, it is giving us the power of that. So it means that when we pick one of the base and then we sum the exponents 2 plus what 4, it's the same as what? This. So this will give us 3 raised to the power what? 6. With this example, it means that when we pick one of the base and then we sum the exponent, we have 3 plus 2 is the same as what? That. So we have 5 raised to the power 5. So we can therefore generalize and say that if you have, let's say, A raised to the power m multiplying A raised to the power n, without fully expanding, we can just pick one of the base and then we add their exponents. So we can therefore say that when two numbers are multiplying and then they have the same base, we pick one of the base and then we add their exponent. And this rule or law is called the multiplication law of indices. So we have our first one. We have A raised to the power m multiplying A raised to the power n is the same as what? A m plus what? N. And this law is called the multiplication law of what? Indices. Let's look at another law. So let's consider these numbers. 3 raised to the power 5 divided by 3 raised to the power 2. Now we want to simplify this. Now we know that this means that 3 is multiplying itself 5 times, and this means that 3 is multiplying itself 2 times. So we can write this as what? 3, we have our division sign. And this means that 3 times 3. Now we want to simplify. So we can see that this 3 can cancel this 3 can cancel this 3. Now we want to write this 3 as an index form or index notation form. So we can write this as what? 3 raised to the power 3. Now let's consider another example. Let's take it that you have 7 raised to the power 3 divided by 7 raised to the power 2. We want to simplify this. Now we know that this can be written as 7 times 7 times 7. And this can be written as what? 7 times 7. We want to simplify. So you can see that this can cancel this can cancel this. We are left with what? 7 raised to the power 1. Now, is there any other way that we can achieve this result without fully expanding and then cancelling? I believe that your answer is yes, because you can observe that when we subtract the power of the denominator from the power of the numerator, it is equal to the power of this answer. So this means that when we pick one of the base and then we subtract the exponent of the denominator from the exponent of the numerator, it is equal to what? Expanding and then cancelling. Similarly, when we look at this, when we pick one of the base and then we subtract the exponent of the denominator from the numerator, it is equal to this. So we can therefore generalize and say that when you have two numbers dividing and then they have the same base, what we do is that we pick one of the base, we subtract their exponent. We pick one of the base, we subtract their exponent. So we can therefore generalize and say that a raised to the power m divided by a raised to the power n is the same as a m minus n. This means that when you have two numbers dividing, they have the same base a and a. What we do is that we pick one of the base, we subtract their exponent. This gives rise to the next law, which is called the division law of indices. So we have a raised to the power m divided by a raised to the power n is the same as a m minus what? N. Very good. Now let's look at another law. So let's look at these numbers. Let's take it that you have 3 over 5 all raised to the power, let's say 4. Now this means that the number 3 over 5 is multiplying itself how many times? It is multiplying itself 4 times. So we can write this as 3 over 5 Now looking at the numerator, we can observe that the number 3 is multiplying itself severally. So how many times is the number 3 multiplying itself? So we have 1, 2, 3, 4. So the number 3 is multiplying itself 4 times, and we can use the index notation to represent that. So we can write it as 3 raised to the power 4. Now looking at the denominator, how many times is the number 5 multiplying itself? The number 5 is multiplying itself 4 times, and we can write it as 5 raised to the power 4. Now let's take another example where you have, let's say, 2 over 7 all raised to the power 3. How many times is 2 over 7 multiplying itself? It is multiplying itself 3 times. Therefore, we can write it as 2 over 7 multiplying 2 over 7 multiplying 2 over 7. Now with the numerator, we can use the index notation form to represent it. 2 is multiplying itself how many times? 3 times. So we can write it as 2 raised to the power 3. And then 7 is multiplying itself 3 times. So we can write it as 7 raised to the power 3. Now let's take another example. Let's say we have 3 raised to the 3 over 8 all raised to the power, let's say, 2. Now this means that 3 over 8 is multiplying itself 2 times. So we have 3 over 8. So looking at the numerator, we can write it as 3 raised to the power 2 all over what? 8 raised to the power. So when you have, let's say, a over b all raised to the power n. Following this concept, we can say that a over b all raised to the power n can be written as what? A raised to the power n all over what? B raised to the power n. And this is called power of quotient of two numbers. So we have the power of quotient of two numbers where we have a over b all raised to the power n can be written as what? A raised to the power n all over b raised to the power n. Let's look at another law. So let's take it that you have the number 2 raised to the power 3 all raised to the power 2. 2 raised to the power 3 all raised to the power 2. So we call this two groups of 2 raised to the power 3. So we can rewrite this as 2 raised to the power 3 and then we have 2 raised to the power 3. And we know that this can be written as what? 2 times 2. And then this can be written as what? Now looking at this, how many times is the number 2 multiplying itself? It means we have to count 1, 2, 3, 4, 5, 6. It means that the number 2 is multiplying itself how many times? 6 times. So we can write it as 2 raised to the power 6. Let's take another example. When you have, let's say, 5 raised to the power 2 and then all raised to the power 4. This means that we are going to have 4 groups of 5 raised to the power 2. So we can write this as, and we know that this can be written as what? 5 times 5. And this can be written as what? 5 times 5. This can be written as what? 5 times 5. And this can be written as what? 5 times 5. Now, what can you observe from these two examples? This and then that. This and then that. You can observe that when you multiply 3 by 2, it is giving us this. When you multiply 2 by 4, it is giving us what? This. So it means that when you have, let's say, 5 power 2 all raised to the power 4, it is the same as taking the base and then you have 2 times 4. And this is giving us 5 raised to the power 8. So when you have 2 raised to the power 3 all power 2 can be written as 2 and then we have 3 times 2. And this gives us 2 raised to the power 6. So when you have, let's say, a raised to the power m all raised to the power n, it is the same as a raised to the power m multiplying n. And we call this the power law. The power law. So we have our fourth law. So we have a raised to the power m multiplying a raised to the power n gives us what? A multiplying m and then n. Now let's look at some few properties of indices. So in doing that, let's go through this activity and then come out with our observation. So let's take it that you have 4 raised to the power 2 divided by 4 raised to the power 2. Now 4 raised to the power 2 means 4 times 4. And 4 times 4 is what? 16. So we have 16 divided by 16. Now applying the laws of indices, when two numbers are dividing, they have the same base. We pick one of the base, we subtract their exponents. So when you come here, this is going to give us 4 raised to the power what? 0. Now 16 divided by 16 will give us what? It will give us 1, right? So we have 1. And this is equal to what? 4 raised to the power 0. Let's consider another example. Let's take it that you have 5 raised to the power 3 divided by, let's make it 3. 3 raised to the power 3 divided by 3 raised to the power 3. Now we know that 3 raised to the power 3 is what? 3 times 3 times 3, and that gives us what? 27. So we have 27 divided by what? 27. Now applying the laws of indices, we can write this as 3 raised to the power 3 minus 3. So we have 3 minus 3 will give us what? 0. Now let's continue. 27 divided by 27 will give us what? It will give us 1. And then we have 3 raised to the power. Let's look at the last example. Let's take it that you have 5 raised to the power 3 divided by 5 raised to the power 3. Now this is the same as what? 5 raised to the power 3 minus 3, right? Now 5 raised to the power 3 gives us what? 125 divided by 125. And this is the same as 5. 3 minus 3 will give us what? 0. 125 divided by 125 will give us what? 1. And then 5 raised to the power 0. Now what can you observe from these 3 examples? You can observe that 4 raised to the power 0 is 1. 3 raised to the power 0 gives us what? 1. 5 raised to the power 0 is also 1. So we can therefore say that any number raised to the power 0 is 1, with the exception of what? 0. So we can conclude and generalize that any non-zero number raised to the power 0 gives us 1. That is one of the properties of indices. So when you have 1000 raised to the power 0 is equal to 1. 2000 raised to the power 0 is equal to 1. Any non-zero number raised to the power 0 gives us 1. So we are adding to it. Let's look at another property of indices. Now let's take it that you have the number 1 over 2. 1 over 2. Now we can write this 1 over 2 as 2 raised to the power 0 all over 2. Now you know that any non-zero number raised to the power 0 gives us 1 from this property. So it means this will give us 1 and we are back to 1 over 2. Now from here, applying the division law, which is this, we can write this as when two numbers are dividing, they have the same base. We can take one of the base and then what do? We subtract their exponent. Remember, this is raised to the power 1. So we can write it as this. Now this will give us 2 raised to the power 0 minus 1 give us minus 1. So it means that 1 over 2 is the same as what? 2 raised to the power negative 1. Let's take another example. Let's take it that you have the number 1 over 3. Now we know that we can write this as 3 raised to the power 0 all over what? 3. Property 1. That is any number raised to the power 0 is equal to 1. So we can write this as that. Now applying the division law, when two numbers are dividing, they have the same base. What do? We pick one of the base, we subtract their exponents. So this gives us 3 raised to the power negative 1. So you can therefore say that 1 over 3 is the same as what? 3 raised to the power 1. I guess you are following. Let's take another example. So we have the number 1 over 5. We can write this as 5 raised to the power 0 all over what? 5. Applying the division law, we are going to have 5 raised to the power 0 minus 1, and we have 5 raised to the power negative 1. Now, do you agree with me that if I write 1 over a, I can rewrite it as a raised to the power 0 all over what? A. Applying the division law, when two numbers are divided, they have the same base. You pick one of the base, you subtract their exponent, and this gives us a raised to the power negative 1. So it means that when you have 1 over a or 1 over any number, we can write it as a raised to the power negative 1, and we call this the negative index. We call it what? Negative index. So this is the second property that we are looking at. 1 over a can be written as a raised to the power negative 1. So let's look at the next property. So let's consider the number 3 over 4 all raised to the power, let's say, negative 3. Now from this law, it means you can write this as what? 3 raised to the power negative 3 all over 4 raised to the power negative 3 from this law. Nowadays, we can still write it as 3 raised to the power negative 3 multiplying 1 over 1, 4 raised to the power 3. Now, this is the same as that because when you multiply this by 1, we are getting back this. So, this is the same as what? That. Now, looking at this, from this property, we can write this as what? So, we said that 1 over a can be written as a raised to the power negative 1. Therefore, when you have 3 raised to the power negative 3, we can write it as what? 1 over 3 raised to the power 3. So this is the same as what? That. So let's continue from here. So this is the same as 1 over 3 raised to the power 3. Then we have this. Now we don't want the negative. And we know that this 4 raised to the power negative 3, applying this property can be written as 1 over 4 raised to the power positive 3. So in place of this, we are going to write that. So we have 1 over 4 raised to the power 3. Good. Let's continue. Okay, let's continue from here. So we have 1 over 3 raised to the power 3 times this is going to give us 4 raised to the power 3 all over 1. Now let's multiply the numerators. 1 times 4 raised to the power 3 will give us what? 4 raised to the power 3. 3 raised to the power 3 times 1 will give us what? 3 raised to the power 3. Now we can rewrite this as what? 4 over 3 all raised to the power 3. Now what can you observe from this and then that? You realize that with this we are having 3 as the numerator, but with this we have 4 as the numerator. So we have reciprocated this to become this. So with this our denominator is 4, but the 4 has become the numerator. So we have reciprocated this, and then the negative index has changed into what? A positive index. I believe you are observing it clearly. Let's take another example. Let's take it that you have 5 over 6 raised to the power negative 2. Now we know that this can be written as 5 raised to the power negative 2 all over 6 raised to the power negative 2. Now this, we can write it in this form. So we have 5 raised to the power negative 2 times what? 1 over 6 raised to the power negative 2. Now applying this concept, we can write this as 1 over 5 raised to the power 2. And we can write this as what? 6 raised to the power 2 all over 1. Now we have 6 raised to the power 2 all over what? 5 raised to the power 2. And we can write this as 6 over 5 all raised to the power 2. So you can observe that looking at this and that, we have just reciprocated this to become this. And then the negative index has changed into a positive index. So this means that when you have, let's say, a over b all raised to the power negative index, what we are going to do is that we are just going to reciprocate these two numbers to become b over a, and then the negative index will become what? A positive index. And this property is called negative power of quotient of two numbers. Negative power of quotient of two numbers. So let's add it to the property. So we have a over b all raised to the power negative n is the same as reciprocating it b over a, and then the negative index will change to what? A positive index. Now let's look at the last one. We have, let's say, 25. Let's call root of 25. Root of 25. So when I ask you to find root of 25, I believe you are going to say that the root of 25 will give us what? 5. What about root of 9? I believe you are saying that root of 9 will give us what? 3. Now let's look at this. 25 raised to the power half. 25 raised to the power half. Let me ask you this question. To what base index 2 will give you 25? To what base index 2 will give you 25? In other words, we can write 25 in an index notation form as what? 25 can be written as what? 5 raised to the power 2. So in place of 25, you can write what? 5 raised to the power 2, or raised to the power half. Now we know that we are going to have 5 and then 2 times what? 1 over 2. To realize that these two will cancel these two, we are left with what? 5. So it means that 25 raised to the power half is 5, and root of 25 is 5. Let's look at root of 9. Now we have 9 raised to the power half. Now we know that 9 can be written in an index form as what? 3 raised to the power 2, because 3 times 3 gives us what? 9, and this can be written in this index form. So you can write 9 as what? 3 raised to the power 2, or raised to the power what? Half. Now this can be written as 3 and then 2 times what? 1 over 2. So from this can cancel this, we have what? 3. So you can see the root of 9 is giving us what? 3, and then 9 raised to the power half is giving us what? 3. So do you agree with me if I say that the radical sign or the root sign is the same as a power of half? So this means that when you have root of any number, let's say a, is the same as what? A raised to the power half. I believe you are following. So we have, now let's look at another one. We have cube root of 8. We want to find the cube root of 8. And then we want to find the cube root of 27. Now I believe you are saying that cube root of 8 is what? 2. And then cube root of 27 is what? 3. Now let's write this as 1 over 3. 8 raised to the power 1 over 3. We know that 8 can be written in an index form as 2 raised to the power 3, because 2 times 2 times 2 will give us 8, and we can write this as an index form as this. So this is the same as 2 raised to the power 3. Now when you do some simplification, you are going to get 2 raised to the power 3 multiplying 1 over 3. So you can see that this 3 will cancel this 3, we are left with what? 2. Let's look at 27. So we have 27 raised to the power 1 over 3. Now 27 can be written in an index form as well, 3 raised to the power 3. Because 3 raised to the power 3 gives us what? 27. So we can write it as 3 raised to the power 3, or raised to the power 1 over 3. So we can write this as 3, and then 3 raised to the power 3 times 1 over 3. So this will cancel this. We are left with what? 3. So you can see that cube root of 8 is giving us 2, and 8 power 1 over 3 is giving us 2. So do you agree with me that the cube root sign is the same as what? A power of 1 over 3. So therefore, cube root of any number is the same as what? So we can add it to 8. Cube root of any number, let's say a, is equal to a raised to the power 1 over 3. Good. So we can therefore continue and then generalize and say that the nth root of any number is equal to that number raised to the power 1 over n, as easy as A, B, C, D. This brings us to the end of today's lesson. In our next lesson, we'll be looking at the application of these very laws now that we understand the laws. See you tomorrow. Bye-bye.